Namaste and welcome everybody to the Transitional Artificial Intelligence Research Group Seminar Series. Today we have Chen Wang, who did a master's by coursework thesis in the area of natural language processing with me. So the topic is longitudinal sentiment analysis of Sinophobia during COVID-19 using large language models. Chen Wang can begin.
Okay. Good afternoon, everyone. My name is Chen. Today, I'm going to present our project on longitudinal sentiment analysis of xenophobia during COVID-19 using large language models. I will walk you through the background of the study, the motivation behind it, the methodology we used, and the key findings of our research. The COVID-19 pandemic has greatly affected our world, impacting health, economies, and social interactions. One troubling consequence has been the rise in xenophobia. In our study, we focus on Sinophobia. Sinophobia or anti-Chinese sentiment has significantly increased during the pandemic. It's crucial to understand this sentiment to address its social and psychological impacts. Our study aims to develop a sentiment analysis model to identify and evaluate xenophobic sentiments on social media between April 2020 and January 2022 in 6 countries. This will help us understand how these sentiments have evolved during the pandemic. While there have been numerous studies on the impact of COVID-19, few have specifically focused on xenophobia using advanced sentiment analysis techniques. Existing research tends to be theoretical or relies on smaller sample sizes and some qualitative methods, which can be limited in scope. Our study aims to fill this gap by providing a large-scale, real-time analysis of social media data. Also, we use longitudinal analysis to provide deeper insights into the evolution of these sentiments. Large language models, or LLMs, are powerful deep learning models which are pre-trained on vast amounts of text data. They are good at understanding and generating human language and are used in various applications. For example, like text summarization, translation, and more. Examples include GPT-3 and BERT. In our project, we'll be using BERT. Sentiment analysis, on the other hand, is an NLP technique used to identify and extract the sentiment or emotional tone from text. It helps in determining whether the sentiment expressed in a text is positive, negative, or neutral, and is widely used in market analysis, customer feedback, and social media monitoring. In this section, we first look at the use of LLMs in sentiment analysis. These models have been incredibly successful, but they also face some important challenges. For example, biases in the training data can affect the results, leading to skewed sentiment analysis. On top of that, LLMs require a lot of computational power, and there are concerns around privacy. It gets even more complex when dealing with social media language, which can be full of sarcasm, slang, and abbreviations. Despite these challenges, advancements like GPT-3 have made a huge difference. They've improved accuracy in detecting sentiment, especially in more complex scenarios like analyzing market sentiment. Next, we looked at research specifically focused on xenophobia during the COVID-19 pandemic. Studies showed how anti-Asian sentiment really surged during this time. Another study used large datasets from platforms like Twitter and 4Chan to track how xenophobic slurs spread and evolved during the pandemic. Finally, we discussed the importance of longitudinal analysis. This is a method that allows researchers to track changes over time, which is key when you want to understand how public sentiment reacts to big events. For example, studies by Lucas and Wang used longitudinal analysis to track the psychological effects of COVID-19. In the context of our work, Chandra and Krisha applied this approach to the sentiment tracking, showing how public mood shifted during key moments like the vaccine rollout and the emergence of new COVID variants. And our study utilizes two main datasets. The first is the global COVID-19 Twitter dataset, which is an extensive collection of tweets related to COVID-19 from March 2020 to February 2022. This dataset includes tweets from 6 countries, Australia, Brazil, India, Indonesia, Japan, and the UK. For example, we have over 3 million tweets from Australia and nearly 17 million from the UK. This large dataset allows us to conduct a comprehensive analysis of public sentiment across different regions. As for the second one, we used Sinophobia dataset to train and test the model. This dataset compiles over 104 million tweets and Weibo messages about COVID-19. This dataset covers tweets in 6 languages, English, Spanish, French, Arabic, Italian, and Chinese, collected between March and May 2020, and the tweets were labeled into 10 sentiment categories. Here is an overview of our methodology framework. This framework consists of 5 major stages. In the first stage, we pre-process both datasets to ensure data quality and relevance. This involves converting text to lowercase, expanding contractions, removing hashtags and mentions, and handling emojis. We also performed filtration on the global COVID-19 Twitter datasets using specific xenophobic keywords such as China, Chinese. And in the second stage, we perform n-gram analysis on the filtered data to identify common terms and phrases in the tweets. We then correlate these findings with COVID-19 infection rates to explore potential relationships between the spread of the virus and the prevalence of xenophobic sentiments. In the third stage, we fine-tune a pre-trained BERT model using the cleaned Sinophobia dataset. I will expand this in the next few slides. In the fourth stage, we use the fine-tuned BERT model to classify tweets into multiple sentiment categories. For example, optimistic, thankful, anxious, and more. Finally, in the fifth stage, we conduct longitudinal analysis to track sentiment changes over time. We generate visualizations such as sentiment distribution, n-grams, and polarity scores. This table presents the keywords we use to identify xenophobic contents in social media posts. The first 3 rows show common terms associated with China, such as Chinese, PRC, and Wuhan. The remaining terms in the table are the most frequent racial slurs we identified from the related works. By filtering social media posts with these keywords, we were able to isolate content that contained explicit or implicit xenophobic sentiment. BERT, which stands for Bidirectional Encoder Representations from Transformers, is a state-of-the-art model in natural language processing. It has been pre-trained on a large corpus of text data, allowing it to understand and generate human language with high accuracy. We fine-tuned a pre-trained BERT model using a Sinophobia dataset, which was split into 90% for training and 10% for testing. The key hyperparameters used include something like the learning rate, the batch size, and so on. Also, we use the Adam optimizer, which is efficient for large-scale neural networks. The model architecture, it comprises 3 layers. We start by initializing pre-trained weights from BERT-based uncased. Next, we add a dropout layer to prevent overfitting, and then a linear layer that maps the output to the 10 sentiment categories. Now I'm going to display the results. Firstly, we perform data analysis on the filtered data. The first graph here shows xenophobic tweets from April 2020 to January 2022. Notable spikes occur in May 2020, early 2021, and December 2022. December 2021. Comparing this with the COVID-19 cases graph here, we can see the correlation between them. The spikes in tweets align with surges in cases, particularly in early 2021 and December 2021. After the BERT model is trained, we use several metrics to measure its performance. Our model achieved a harming loss of 0.13, indicating a relatively low fraction of incorrect labels, and the LRAP score is 0.77. This means that in 77% of the cases, our model ranks the correct sentiments higher than the irrelevant ones. The macro F1 score was 0.52 and the micro F1 score was 0.58, both of which indicate strong overall performance in classifying the tweets. Now, to delve deeper into the content of the extracted xenophobic tweets, we performed n-gram analysis. N-grams are contiguous sequences of n items from a given text. A bigram is a sequence of 2 adjacent words, while a trigram is a sequence of 3. The two figures show the top 15 bigrams and trigrams of the whole dataset. The most frequent bigrams include coronavirus vaccine, Chinese Communist, and Communist Party. The top trigram includes Chinese Communist Party, Wuhan Institute Virology, and Chinese coronavirus vaccine, indicating the discussions about the vaccine, the Chinese government and its ruling party were strongly focused. And also the Wuhan Institute Virology, it was the center of the lab leak theory. In the next few slides, I will show the top 15 trigrams separately for the selected countries. For all of the trigrams of the 6 countries, the most frequent trigrams in these figures include Chinese Communist Party and Wuhan Institute Virology, which is similar to the worldwide results that we saw in the previous slide. In this slide, we are showing the top trigrams for Australia and Brazil. We can see the Brazil figure suggests a focus on the impact of the virus on children and face mask usage. For the India and Indonesia, there's a strong interest in China's role in vaccine development and distribution. In these 2 figures, we see the trigrams of UK point to concerns about the lab origin theory. So overall, we can say that the Asian countries show a greater interest in Chinese vaccine. On the other hand, Australia and the UK care more about the origin of the virus. Also, for these 2 countries, there are more xenophobic-related trigrams among the top 15 compared to other countries. In this part, we used our methodology to classify sentiments. This pie chart shows the percentage of sentiment labels. The majority of tweets have one or two sentiment labels. For the bar graph, the distribution patterns are quite similar across all countries. Notably, the UK, Australia, and India have more tweets with two sentiment labels, indicating a more complex sentiment expression in these areas. Next, we conducted a longitudinal analysis of the sentiments expressed in tweets across different countries from April 2020 to January 2022. The first figure shows the total number of tweets with each sentiment. Annoyed is the most common sentiment with over 40,000 tweets. This is followed by denial and official report. The label empathetic is extremely low, nearly zero, which is quite surprising. It's like given the catastrophic impact of COVID-19 shared by all humankind, it's expected to be a less rare emotion. For the country-wise analysis shown in these two figures, depicts the percentage distribution of specific sentiments across the selected countries. In the first one, annoyed is the dominant sentiment in all countries, especially in Australia, India, and the UK. In the second one, denial is the most frequent sentiment. So for the polarity scores, the polarity score measures the sentiment in a text ranging from -1 to 1. Positive scores indicate positive sentiments, and negative scores indicate negative sentiments. We evaluated the polarity scores of the tweets using two methods. The first one is the text blob, and the second one is the costume weight ratio approach, which is like you assign the weights to each sentiment. These two figures show the distribution of polarity scores. The first one shows the text blob score, where most tweets are close to zero, indicating neutral sentiment. The second figure shows the costume weight polarity score. Like text blob, it shows a concentration around zero, but also reveals distinct peaks at some negative scores, especially at -0.5. By looking at the box plot and the volume plot from 6 countries, the median polarity scores for all countries are slowly below zero, and the peaks are at around -0.5 and 0. Both figures indicate an overall negative sentiment, but we can see Australia, India, and the UK show a lower bottom quartile. In these figures, we observe the mean polarity scores calculated using both of methods from April 2020 to January 2022. Comparing these two figures, we can see the text blob method shows more positive polarity scores compared to the costume-weighted approach, suggesting that the latter is more sensitive to negative sentiments. If we analyze the mean polarity with the COVID-19 cases figure together, it's like down here, we can see a noticeable correlation. For instance, in May 2021, India experienced a significant peak in new COVID-19 cases, which aligns with a sharp dip in polarity scores in both methods. Conversely, countries like Japan and Australia, which had relatively stable COVID-19 case numbers, show less fluctuations in their sentiment scores. Also, we can see a significant drop in July 2021 and a subsequent rise around November 2021. Hence, we analyzed the top 15 trigrams within these 2 months to see what happened. In July 2021, the top trigrams like coronavirus origin study, plan second phase, and China reject plan show the global focus on investigating COVID-19's origin. For November 2021, the top trigrams include dose coronavirus vaccine, billion-dose coronavirus, and Chinese journalists jailed. This reflects a period more centered on vaccination efforts and some global events. By comparing the top 15 trigrams in these 2 months, we noticed a significant psychological shift in people as the pandemic went on and appeared to be out of sight. People's focus transferred from why did this happen to when and how this can end, and resulting in a rise of polarity scores. Our study revealed key insights into how xenophobic sentiments evolved during the pandemic. We found that the polarity scores closely tracked COVID-19 case spikes. More cases led to more negative sentiments, especially during major outbreaks and public health interventions. Our sentiment analysis models were robust, with 91% of tweets consistently assigned 1 or 2 sentiment labels, which aligns with the previous studies. Negative sentiments dominated, while empathetic responses were notably absent compared to previous studies. And we also observed the frequent use of politically charged terms, highlighting the politicization of discourse around the pandemic. This further fueled negative attitudes towards China. And for the example tweet at the bottom of this page, it has 2 labels, official report and anxious. While the official report label makes sense given the factual nature of the tweet, the anxious label reflects the underlying concern the message conveyed. This shows how official statements during a pandemic often carries an emotional weight that could easily be misinterpreted or even manipulated. It underscores the importance of clear and transparent communication, especially during a crisis, to prevent misinformation and maintain public trust. Our study has several limitations. First, our datasets are from Twitter, which may not represent the broader public opinion, and the use of slang, abbreviations, and emojis can affect accuracy. For the model limitations, we have a look at these 2 sample tweets first. The first tweet was classified as positive, but it's clearly an irony. Handling this kind of content remains challenging for our model. Lastly, despite the cleaning efforts that we have made, noisy data still exists. For example, the second sample tweet. The tweet mentioning PRC test was filtered as xenophobic, although it's more likely referred to PCR test for COVID-19, not People's Republic of China. These limitations highlight areas for future improvement. In conclusion, our BERT model worked fairly well, but it struggled with complex sentiments like sarcasm and irony. We noticed a link between spikes in xenophobic tweets, lower sentiment scores, and major COVID-19 outbreaks. Most of the tweets about China were negative with sentiments like annoyed and denial. From our n-gram analysis, we can see frequent usage of political terms. It was clear that discussions about COVID-19 were heavily politicized, showing how political narratives shaped public sentiment during the pandemic. Therefore, we can say that xenophobia is driven by not only the association of Chinese people with the coronavirus, it was a complex phenomenon influenced by health, race, and politics. For future research, we should look at data from more platforms, for example, Facebook's, Instagram. Using more advanced language models like GPT could improve our analysis. Also, considering cultural, religious, historical, political, and economic factors will give us a better understanding of what drives xenophobia during the pandemic. Thanks for listening. And now I'll be giving a quick overview of our GitHub repository. I'll stop sharing for now because this is a quick over. I'll just give a quick overview of our GitHub repository. The repository consists with 4 files, BERT model, results, 6 countries, and visualization. For the BERT model file, it contains the Jupyter notebook for model training and testing using SimWave dataset. First, we pre-process the dataset by cleaning the tweets, expanding the contractions, converting emojis and abbreviations into their textual equivalents. This ensures that the data is structured and ready for analysis. So this is the data set that we got after pre-processing. We can see they are clear and all lowercase. Because this is the data set for training, so we will have the labels already. And then it will be, and it's split into 90% for training and 10% for testing. Next, we tokenize the tweets using a pre-trained BERT tokenizer, which transforms the text into input tokens that the model can interpret. And these are the parameters that we'll be using. Then the model was being trained by 4 epochs. After training, we evaluated the model on the text set using metrics such as the Hamming loss, Jaccard score, and these are which we saw in the slides. And for the results file, it contains all the CSV files for the 6 countries. Each includes the original tweet, the text after pre-processing, and the sentiment labels for each tweet. In the file 6 countries, these are 6 Jupyter notebooks. They actually have similar code, but just for different countries. So we'll just go through the Australia notebook. Firstly, we filter the dataset with the keywords that we just saw in the slides. We do this first because this can reduce the total amount of the data. It will be easier for pre-processing. And this is the lens after filtering. Then for the pre-processing, it's similar with the SimWave dataset in the model training part. Now we initialize a custom dataset class. This class tokenizes the tweet text using the BERT tokenizer. The text is encoded and padded to a maximum length of 256 tokens. These steps are similar with the model training. And we then load the pre-trained model that we saved before. Finally, the sentiment predictions are assigned back to the dataset. And then we put the date column back. This is for the visualization. Like when we plot the figures, we'll need to see how it changes over time. And then the results is ready for further analysis. So the results here is actually the ones here. And then the visualization file. In this notebook, we first read all the CSV files and combine them into a whole data set. And then we plot the figures that we need. Like these ones. these are the n-grams with different countries and different time intervals. And for the polarity score, we'll just rate the combined data. And yeah, we used two different methods, as we mentioned. The first one is the text blob. And we just, to calculate the text blob polarity, we're just using the library. It has a lexicon which has marks for each words, which is like very easy to calculate. And for the costume weighted, we assign the weight ratios for each labels, and then we calculate the average here. Yeah, and then we do the plots. And this is our data resource. Okay, thanks for listening.
Thank you, Chen. So we open the floor now for questions and comments.
Should I stop sharing or?
Yeah, you can just share your slides for now.
Okay.
Right. So anybody, any comments? Yes, please come in front, Samal. So Chen is updating the README of the paper. Uh, in the README, this paper is actually, you've seen in the email, there's an archive of the paper. Chen, you can share the archive of the paper. There's an archive
Oh,
link
okay.
paper, yeah. So any other questions?
I'll go find it in the email.
Of the outbreak. Yeah, thanks, Chen. Can you go back into the presentation? Ratnil has a question about the peak. So let's go into the slides about the peak.
The peak.
The peak of the polarity scores, you know, those plots that show the peak of the polarity scores? Yes, this one, perhaps. If you could put it on presentation mode. Right, so in the peak, what is the question? Or the drop in case, consumed in case, how much negative sentiment there is, it's the polarity. After COVID, after the has this changed? Has there been a significant difference? So does the data set cover post-COVID? The definition of post-COVID, I think the definition of post-COVID is perhaps after 2023. So our data set is covering from 2020 to 2022 January, right? So
Yeah.
after COVID, I mean, it's a good study to extend this because we've also had a situation where Twitter has changed drastically with X, and so we have also another sister study which is continuing, which is on Hindu phobia during COVID-19. So we have a Sinophobia and a Hindu phobia project. So in the Hindu phobia project, what we found was that during COVID-19, in the data set, the COVID-19, the global data set that we have released in Kaggle, that data set basically, there was not much Hindu phobic tweets actually during 2020 and 2021, which was in the same time zone, right? So if we compare these results with what the analysis we've done on the same data set for the Hindu phobic tweets, we can't find much Hindu phobic tweets. but there was a lot of Hindu-phobic tweets in Twitter, but they were deleted. They were deleted, right? And so then my student intern who is in India, he had to extract the data for 2023 and do the same analysis during 2023, which had 2023, I mean, in my memory, had far less Hindu-phobic tweets related to COVID because COVID was not reported that much in the newspapers. And there's a vast amount of Hindu-phobic tweets relating to stuff to COVID and all that in 2023. And since Elon Musk came in, he has not deleted the data in Twitter, right? So it's a very strange thing that we have seen that in Twitter retained the xenophobic tweets. They deleted the Hindu-phobic tweets before Musk, and after Musk, they are now being more open to the negative tweets and the hate speech. They're like, we are not going to delete it. We want Twitter to be as open as possible. So this is a kind of an interesting study in terms of how Twitter is also evolving with time. The thing is, there's a lot of constraints in these type of studies, especially gathering the data set, which is a vast amount of work, and we have 2 or 3 other papers published with this data set, the global COVID-19 dataset, and I put a small paper of a few pages in SSRN, and it's linked with the Kaggle. And getting that dataset was very hard for us because the university was not giving us the resources to download the data. And at that time, we were running a server in the office. We were not allowed to run it here because the thing is, like, we had volunteers working on the project. You need to have, when you're downloading data from Twitter, you need to download every day. Every day you need to check that app. So we had to do that for 6 to 9 months, right? And it was a very difficult process. And then we have, and there's a lot of policies that bars people from sharing data from Twitter that you have downloaded. So you have to really remove all the tweet handles. You cannot, you have to anonymize the data. And even then, there's a Twitter can even then ask you to put it down, and that has happened to a number of people. It hasn't happened to us yet, but if it happens, then we'll unfortunately have to put that data set down. It's around 20 GB, and in this data set, we have purposely removed the United States from the data because that is, I don't know, 8 to 10 GB, just that data. And it's very hard for the BERT models to, because that's the most amount of data in the United States. Yeah. So as Twitter is evolving with time, we're going to get far more and more data. And the other part is, the other limitation here is that we don't have data from China because China doesn't have Twitter. And we are going to extend this type of studies in future events and situations.
What about going the other way? Like, it's no one, I think, in the room would doubt that there was really a riot in Sinophobia during COVID, but I'd say we would also probably agree there was a lot of Sinophobia in Australia before COVID as well. Same kind of benchmark.
Yeah, I think, I mean, we can do such studies, and we need to basically extend this COVID-19 data set. But then this is related to COVID-19, the Sinophobia. And that type of work, it's just mining a lot of data. And
even seeing how much it increased during COVID, like, it's hard to know.
yeah, it's a difficult thing. So any other questions before we end this session? Okay, I would like to sincerely thank Chen for taking a really big effort to really present this from China after going back and being very committed to the project. Thank you, Chen, and we hope that we get this paper published in the coming year. And thank you very much. Okay, bye-bye. Thanks, everyone.
Bye bye. Thank you.